Hello Earth Science students, today is our lesson on running water and stream transport. Let's start with running water. So running water is just referring to any kind of like stream or river where the water is moving. In the picture in the background of this slide we have a beautiful image of the Missouri River winding its way through Wolf Creek Canyon, which is what you go through when you're traveling between Helena and Great Falls. So the parts of the water cycle that are involved with running water are surface water, right? We don't have groundwater going on and we don't have atmospheric water going on in a river. And surface runoff in particular. Pretty much any type of flowing water on the surface is a form of surface runoff. So the whole reason that streams flow is because of gravity. The force of gravity is constantly pulling water down towards lower elevations, so wherever water lands on the surface of the earth, it will be pulled downward by gravity. So the velocity of a stream is referring to how fast the water is flowing through the stream channel. This depends on several factors. First is gradient. Gradient is often just called slope, and this is the vertical drop per distance of a river from its headwaters to its mouth. So if you find the elevation of the headwaters, find the elevation of the mouth, and then find the difference between the two and compare that to how long the river is, you can get the gradient. And so these two pictures are just showing different gradients. The one on the right is a very steep slope, a young river up near its headwaters, and the one on the left, that's the Mississippi River. It's been working its way downhill for a very long time. It has a much gentler slope at this point in the stream than it would near its headwaters. Stream velocity also depends on certain channel characteristics, so the shape of the channel, the size of the channel, and in particular the roughness of the channel. Because the rougher the channel is, like the more stuff that's in the stream channel that the water has to flow around, that creates more friction against the water as it's flowing, and then that slows the water down. So if you look at this picture on the left here, sometimes if we have a little river that's eroding itself too much, it's eroding its channel too much, we will artificially dump in some stuff like boulders and logs and things to create some friction to slow the water down to reduce the rate of erosion. The final main factor that influences stream velocity is the discharge of the river. So discharge is just referring to the volume of water that's flowing past a certain point in a certain amount of time is how we measure discharge. So pretty much it's just how much water is flowing through the stream channel. We can calculate this easily. You go to a point in the stream and you get the width of the stream, so you measure across the stream channel in meters. You take the depth of the stream, so you just like put a stick in and see how deep the water is, again in meters, and then you multiply that by the velocity of the water, so how fast is the water flowing right there, and you can find the discharge of the stream in cubic meters per second. Remember, a cubed meter is referring to some type of volume, and per second means it's a volume per a speed. So that's what we have for discharge. So an example of a river with really high discharge is the Amazon River. So it has about 212,400 cubic meters flowing past a certain point in 1 second of time. So that's a huge amount of water. The discharge of rivers changes with the seasons. As you can see in this graph that I have to the right here, you can see that there are peaks associated with higher daily precipitation. And so precipitation is a really strong factor that influences the amount of discharge in a stream, and also snowmelt. So springtime is the season of the year that has the greatest stream discharge in general anywhere in an area, because typically spring is more rainy and also the snow is starting to melt, so all of that water will flow into streams because of surface runoff and add to the discharge. The discharge affects the size and velocity, so rivers will grow, sometimes they'll even flood during times of high discharge, and then the water also gets faster just because there's more water moving. It has a little bit more momentum, it can move faster. Flooding can be caused by urbanization. So urbanization is people going into a place and building our nasty people stuff where there used to be just soil. And so this causes problems for during the rainy season anywhere where there's an urban area. We put pavement over everything because, you know, we gotta have stuff to drive on, right? And so that means there's less exposed soil. And if there's not very much soil, then the water, when it hits the ground, it can't infiltrate into the ground, and so it's going to run off instead. And so when it runs off, it, follows gravity and follows the path of least resistance and goes toward whatever body of running water it can find. And so all of that extra runoff adding to a stream discharge can cause flooding. So stream efficiency has to do a lot with the discharge. So as the gradient decreases or as the stream channel gets flatter, the discharge will increase, so there can be more water flowing past a certain point in a certain amount of time when the stream is flatter. And a lot of this has to do with because when streams flatten out, tributaries can join a little bit more easily and they can contribute all of their water to the discharge too. So in general, stream efficiency is a lot greater at lower gradients. So stream efficiency, the amount of stuff that they can carry and the amount of water moving through is higher the closer you get towards the mouth of the river. And we can look at these stream profiles where in the headwaters there's a lot of the steep gradient, there's small tributaries joining in occasionally, and then as the stream works its way closer towards its base level, the ocean in this case, a lot more tributaries can join further downstream, and then we end up with a wide river channel close to the mouth. So base level is just the lowest point that a stream can erode its channel to. Typically this is going to be when it enters another body of water. The ultimate base level, meaning the lowest point that any river on Earth can erode its channel to, is sea level. But there can be temporary base levels, like when a stream enters into another lake or hits a layer of resistant rock that's not eroding very fast when it enters another stream, or it could even be an artificial temporary base level when a river hits a dam. So this is just a little picture showing that the stream has eroded its way down towards its base level, and the base level is the same as sea level in this case. All right, now moving on to stream transport, and this is talking about the ways that streams can move sediment. So the main way that streams pick up sediment is erosion. Erosion is just a process of soil and rock and other sediment being worn away by the water. This can happen by a couple of mechanisms. First is abrasion. So abrasion is like sediment that's already in the water scraping against sediment that's on the bank and kind of scraping it away from the channel, and so then it can get into the water. And then also dissolving. Water is a very good solvent, so it can dissolve minerals out of the stream channel too. The higher the velocity is of the stream, so the faster the water is moving, the more erosional power it has. So sediment can be transported in three main ways. First is in the dissolved load of the stream. So this is any type of stuff that is dissolved into the water. So it's invisible to us. We can't see it. We have to use tools to measure it. This can be any kind of minerals that came out of rocks. It can be salt, really any kind of mineral that can be dissolved out of rock. This is measured in parts per million or parts per billion. The abbreviation is ppm or ppb. So that is just how much of this mineral is there in the water compared to 1 million or 1 billion particles of water. So if you look on the picture on the left here, you can see this is like a cartoon diagram. The little red and white Mickey Mouse looking things are water molecules, and then the yellow and green chunk in the bottom left is like representing a rock. And so as the water is flowing over that rock, it plucks off individual little bits of whatever that mineral is and then carries them away in the water. And the picture towards the bottom here is just some limestone, and you can see some little holes formed in that limestone from water sitting on top of it, and that water is dissolving the minerals in the limestone. The next form of stream transport is the suspended load, and suspended in this case means like floating. So this is any kind of sediment that's floating in the water. It's small enough that it can be floating in the stream as it flows. So this causes the stream to look muddy or cloudy, or a fancy word that we sometimes use is turbid. The more suspended load there is in the stream, the greater the turbidity is. So the types of sediments that can be carried in the suspended load of a stream are sand, which of course you know sand, you can see the individual grains of sand. Silt, which is like when you go to the lake and you're digging through the sand and you get to some softer stuff where you can't actually see the grains of sediment anymore, but if you rub it between your fingers, you can still feel the grittiness. And then clay is very smooth. The particles are so small, the individual grains of sediment are so small that we can't see them with the naked eye or feel them with our fingers. So the picture in the bottom here, this is a picture of the Milk River of Montana. It's one of the tributaries of the Missouri, and it's called the Milk River because it has a high suspended load. It gives it that kind of cloudy chocolate milk looking color. The final way that streams can transport sediment is in what's called the bed load. It's called the bed load because the bottom of a river is called the riverbed. And so these are just any rocks, pebbles, gravel, anything that's too big to be suspended. It can't float in the water because the water's not moving fast enough. So it just kind of gets pushed and rolled along the bottom of the river. It can move by two main motions. Traction is just really large pebbles kind of being pushed and rolling along the bottom, and then also a motion called saltation, and this is from a Latin word for dancing, and this is little pebbles kind of they can be picked up enough to hop a little bit, but the stream can't keep carrying it, so it gets dropped again. So the bed load doesn't always move. It'll only move when the current is strong enough, so at times of high discharge especially. And the grinding action of the bed load, these rocks scraping against each other as they move through the bottom, is a really important mechanism of stream erosion. So here's just a quick picture showing the different types of movement. We can't see the dissolved load because, again, those dissolved minerals are invisible to us, but you can see the little grains of sediment floating along, suspended in the water, and then the bigger rocks, number 4 and 5, are moving by that traction mechanism, and number 3, those little pebbles, are moving by that saltation. They're kind of hopping along. Water picks them up and then drops them again. Two words that we use to describe the amount of stuff and how big of stuff that streams can carry are competence and capacity. So stream competence is the largest size of sediment, the largest particle size that can be transported by the water. So if you're competent at something, it means that you're good at it, and so this is how good is the stream at carrying big stuff. As velocity increases in water, the competence increases, so the faster moving the water is, the larger chunks of sediment that it can pick up. It's a pretty direct relationship. As velocity doubles, competence will increase by 4 times. So the faster the water, the much larger of stuff the water can pick up. And then capacity is the maximum amount of stuff it can carry at a specific time. And then now as discharge increases, capacity increases. So the more water there is flowing, the more stuff the water can pick up. All right, and now finally on to deposition. So erosion is the wearing away and carrying of sediment by the water, and deposition is when the water drops that sediment. So this occurs when the sediment settles out of the water when the stream drops below whatever the critical settling velocity is, and that critical settling velocity changes based on how big the sediment is. So the critical settling velocity is higher for larger sediment. Stream deposited sediment is called sorted because bigger pieces will drop out of the water sooner. And so you can see that in the sediment column to the right here. There's larger chunks of pebbles and gravel at the bottom, and then there is sand on top and some silt and even some clay towards the very top of the column. So any kind of sediment that is deposited by a stream is called alluvium, and so if you come across some sediment out in the wild and you can see that there's a layer of large sediment and then it gets smaller and smaller as you go towards the surface, then that's the way that you can know that that sediment was deposited by a stream because it is sorted.